So this video is going to be about Chapter 10's last little review we have of the stuff we did before spring break. This is just going to cover some of the word problems that we might encounter that require us to think a little deeper or do something a little bit more unique to them. But in general, when you're doing a word problem, especially with an area or any geometry word problem, you always want to make sure to draw the picture. So even if it's not a good picture, or even if it's just to kind of get your bearings, it's always good to draw a picture so that you know kind of, oh, pardon me there, so that you know kind of how to tackle the problem. It helps kind of structure your thinking. So we have this case here where we have a party planner who's planning a party. Um, they require tablecloths, not clothes, but cloths, for 12 round tables that have an area of that each. The planner has two options. They can rent tablecloths for $18 each, or they can make their own. So they go out and do some research, and they find that the cheapest they can get is a bolt of fabric that's 20 feet wide by 80 feet long for $7.50 each. And it says, what option should they choose? So they want to know which one's going to be cheaper. Well, the first option is pretty easy to figure out, right? If it's $18 each and they need 12 tables, that's going to be 12 times 18. 12 tables, $18 each. Whoops. 12 times 18. That's going to cost them $216. Which, okay, that's that cost. Now you figure out if making our own would be cheaper. So what we have to think here is, okay, how do we get how many of these bolts we need, right? We have a bolt of fabric that's $7.50 each, but I don't know how many of these I'm going to need to get to 12 round tables that have this much of an area each. So what I would do is, let's go ahead and draw a picture right here. I would draw my 12 round tables, which I already did here, and then I would kind of think, okay, each of these has an area of 254.47. So 254.47. And I have a piece of fabric that is 80 feet long and 20 feet wide. I need to figure out how many circles I could cut from this piece of fabric if they're that. Well, in order to know that, what I would need to do is know the diameter or the radius of each circle. Probably the diameter here, that way we can measure lengthwise. I could try to figure out via area and comparing the areas, but it might not be that, even though I might be able to get, like, let's say 5 circles from this, they might not actually be perfect circles, and you'll see what I mean here in a second. So let's try to find the diameter of each circle, or of a circle, because they're all the same, and figure out how many of those would fit on a bolt of cloth, and then figure out how many bolts of cloth we would need to get our stuff here. So if the area is 254.47, remember for a circle, area is pi r squared. So it'd be 254.47 is equal to pi times r squared. So what you would do is you would divide both sides by pi. Let's look at this here. So 254.47 divided by pi. We get basically 81, right? We'll just round it out to 81. So we get 81 is equal to r squared, and then square root both sides. And we get 9 is equal to r. So each radius has a radius, or each circle rather has a radius of 9, which means the diameter of each circle is going to be twice that, or 18. So each circle is basically 18 inches in or 18, sorry, feet in diameter. So how many of those could fit into this bolt of cloth here? Well, I can only fit one vertically, right? Like if I draw a circle here, that's 18. So 18. I'm only able to fit one of them on there. I can't fit two side by side because that'd be 18 and 18, and that'd be more than 20. So I can't fit two circles on top of each other. But I can fit more lengthwise. Well, how many more? Well, if they're 18 units across, essentially 18 feet across, I'm basically figuring out how many 18s can I fit inside 80. So if I take 80, how many 18s can I cut that up into? How many 18-piece sections, which is the division problem. And so we get basically 4, right, if we round down. So 4.4 repeating, and we can't have 0.4 repeating of a circle, so we can have 4 of these circles fit comfortably in there. We'll have a little bit of extra space left over. This is why I said that we might want to use the diameter as our measurement, not the area, because even though you might be able to get, let's say, 5 circles worth of area, the last little bit of area might be all these scraps together might form one more circle that you couldn't quite fit in there diagram-wise, but mathematically with the area it actually works out. So that's why it might be better to use the diameter here as a reference, just so we know that all circles can actually be cut in a perfect circle fashion from this bolted cloth. So we can fit 4 circles, or get rather 4 circles from a bolted cloth. So how many of those bolted cloths would we need? Well, we have 12, and if we get 4 from one, so we're going to need 3 bolts of cloth total. So 3 times 750. Again, 4 circles from one bolt of cloth. We need 12 cloths total. So 12 divided by 4 gives you 3 bolts of cloth that we need. We do some multiplication here. 3 times 750, and we get 211.1.5 rather. So $211.50, which is just a hair less than what we'd have if we didn't do it. So it turns out option B is just a little bit better, a little bit cheaper than option A. Saves yourself some money there. Also, you'll be able to get to reuse the tablecloths evidently. So again, a little bit different than a normal typical word problem. Helps to kind of draw out and, like I said, always show your work so you can kind of see the process of how you're tackling it. Another one here dealing with circles. So we have a pie chart, and this pie chart has a radius of 12 inches. And we want to know, okay, how much area should we give for each slice so that's representing the proportional amount. We obviously don't want winter representing all the area because winter is one of the smaller of the sections that were answered there. So this person asked the students what were their favorite season. They got these answers, and they're going to make a pie chart that has a radius of 12 inches. And they want to know how big to make each sector, to make each slice. Well, remember, the area of a sector is as follows. It's the area of the sector over pi. Now, in this case, since we know the radius, it's 12, but I'll just put an r here. Pi r squared is equal to the degree of the sector over 360. So if you look here, let's say I want to find the winter sector. I almost have everything I need. So x for area. Pi, I know the radius is 12, so pi 12 squared is equal to, I just need the degrees. I don't have the degree number up here to put down. Like if this is my winter section, let's say this is winter, I don't know what degrees to make this because I haven't figured it out yet. So what you want to do to figure this out is figure out, okay, how much of the entire responses does winter represent? So how many responses do they have total? So let's go ahead and add them up here. So we have 6 for winter, 8 for fall, 14, 10, and then 2 for salt and pepper because people obviously don't understand the question. If we add those up here, let's see, that's 20, that's 10, so that'd be about 40, right? Let me just double check. 8, 14, 14, 10, and 2. Right, 40. So how much that is winter? Well, winter is 6 responses out of 40. So winter's fraction is 6 out of 40. For fall, it was 8 out of 40. Spring was 14 out of 40. Summer, you can probably guess, is 10 out of 40. And salt and pepper is 2 out of 40. So what I would do is make these into percentages, or at least decimal forms, like 6 out of 40. Go to my calculator here. 6 out of 40. Try that again. 6 out of 40 is 0.15. So this is about 15% said winter. What about fall? Be 8 out of 40. So 8 out of 40 is 20%. 14 out of 40 gives us 35%. 10 out of 40. So 10 out of 40 gives me 0.25. And then 2 out of 40. There we go. 2 out of 40 gives me 0.05. So we now figured out the percent that each response holds. How do we figure out the degree? Well, we know that the full circle is 360 degrees, right? So I want to know if winter is 15% of the responses, how many degrees does that make? Well, I'm going to take my 0.15 and times it by 360. And that will get me the degree. So 0.15, because that represents winter, times 360 degrees means that should have about 54 degrees for representation. Same for the fall. So fall was 0.2. So 0.2 times 360 is 72. So that should be about 72 degrees for fall. And then you can do the same thing for spring, summer, and salt and pepper. You get the degrees that way. And then you can go back down here, like for winter, 54 degrees. You can go back down here and plug 54 degrees in for the degree spot. Whoops, 54. And then cross multiply. Let me try that again. 54. There we go. 54. And then we cross multiply and divide. So 360x is equal to, if we multiply this out here, so pi times 144, which is what 12 squared is, times 54. We get 2442.9, 2442.9, and then divide by 360. So that divided by 360, 360, gives us 67.9 essentially. So that's how much area to devote to the winter. It should be 67.9, in this case, square inches worth of area to be the proportional amount compared to its response amount. Anything more or less than that would be disproportional and wouldn't accurately represent the amount of people who responded to winter. Now, some of you might be thinking about there's an easier way of doing this, and that's right, because if these are percentages, you could actually, like for fall here, you could actually say this. You could say that, well, if it's 0.2, which is 20%, right? If it's 0.2 of the responses, what's the area of the entire circle? So if we just do that real quick, for the entire circle, full circle, it's pi times 12 squared, which if we do this here, that end up being right here, 452.4. So 452.4. So if I want how much area should be devoted to fall, what you can do to shorten up a little bit is you just simply do 452.4 times 0.2. And if you do that, 452.4 times 0.2, you get 90.48. So 90.48. And that's how much area you should devote to the fall section. It works the same thing for winter as well. So winter we got 67.9. I could have easily done the same thing and did 452.4 times 0.15, this number right here, 0.15, and get 67.86, which is, again, 67.9 when rounded. So you can use the fact that there's percentages here to kind of quickly get your answer by sidestepping this whole area of the sector bit as well. Again, in word problems, there's often multiple ways of tackling things. So if you want to do this for every section, that's fine. If you want to do the shortcut method for every section, that's fine too, if you can figure it out. But again, there's usually multiple routes you can tackle a problem with a word problem. Here we're looking at baking. Sorry, I skipped one there. We're looking at baking here, and we're making a 3-tiered wedding cake. So wedding cakes are usually in circles. You have a circle on bottom, that's your base layer. Then you have a smaller one on top, that's your second layer, and then a smaller one on top of that is your third layer. That's usually how it ends up going. So the base layer, the bottom layer, that area is supposed to be 314 square inches. And it says the second layer's diameter needs to be a third of the base, and the third layer's diameter needs to be a half of the second. So how much area will each tier have? Well, let's go down to base, second, and third. So we'll have base tier, we'll have the second, and we'll have the top. I'll say in a second, I'll say middle, just to keep with my consistency here. So I'll say middle. So middle, mid, mid is my second layer, essentially. So I need to know the areas of each. In order to know the areas, I need to know the radius of each. And so what I can do here is say, all right, the base area is 314, right? 314. And it says for the middle layer, that diameter should be a third of the base's diameter. Well, how do I get the base's diameter? Well, if I know the area, I can go back to my formula here. Area equals pi r squared, and just like the first problem almost, resolve it. So 314 is my area, pi r squared. So divide by pi, divide by pi. We do 314 divided by pi. Gives me 99.9. So we'll just round off and say 100 just to make it easier. So we'll say 100 is equal to r squared, and then square root, square root. We end up getting 10 is r squared. Or sorry, 10 is just r, not r squared. So the bottom layer has a radius of 10 because I just kind of reversed the area to find my radius. Well, it says the second layer's diameter needs to be a third of the base layer's diameter. So I don't need the radius in this case, I need the diameter. So to get that diameter, I just double the radius. So that times 2 gives me 20 is the diameter. So now I'm ready to work with the middle. So now I have 20 as this diameter. This middle needs to be 1/3 of 20, which is going to be a nasty decimal, but we can deal with it. So 1/3 of 20, which is 66.6 repeating. So we'll just count off and say it's, we'll say 6.7. So 6.7 is its diameter, not the radius. And for the top layer, we might as well get this one knocked out of the part too. So the top layer, that diameter needs to be half the second layer's. So half of the second layer's diameter, which we just found is 6.7. So 6.7 divided by 2, which is what half is. 3.4, we'll say, because we're running anything else to the 10th. So 3.4 is that diameter. Now the question says, find the area of each tier. Well, to get the area, I need the radius of each tier, not the diameter. So here, what I'm going to do for middle is I'm going to find the radius by taking 6.7, dividing it by 2. I get that the radius is 3.4. Just kind of found that out with the bottom tier. And for this one, same deal. 3.4 divided by 2 would give me 3.4 divided by 2, 1.7 as my radius. And then now I can go back and use my area formula to solve for the areas of each. So this would be pi times 3.4 squared, and this would be pi times 1.7 squared. So if we calculate these real quick, pi times 3.4 squared, we get 36.3, so 36.3, and then for the next one, we get 1.7, we get 9.1. So these are the respective areas of each layer of the cake, essentially. So again, this one kind of go back and forth between diameter, radius, diameter, radius, diameter, radius. So when you're doing a word problem, it's always important to kind of keep stock of where you're at and what you're working with and what your next step is. What are you doing in this step, and why are you doing it to get to this next step, and how is that next step going to help you to get to the end there? So again, making sure you show your work, organize your mind to kind of get the sequential stuff down. Last one here. So we have a fish keeping rule that says that for every 12 square inches of area, you can have 1 inch of fish. So the length of the fish compared to the area of the fish tank. Now, technically, fish tanks is in volume, but we're going to ignore the height as a factor now and just talk about the area of the fish tank, usually the area at the base of the fish tank, as this problem here. So a person gets an aquarium that's in the shape of a regular octagon, so 8 sides for an octagon. And it's a regular octagon, so all the sides are equal. Side lengths are 15 inches, and the apothem is 20. What's the maximum inches of fish they should have in their aquarium? So once again, let's draw this out here. So we have 1, 2, 3, 4, 5, 6, 7, 8. And we're going to assume it's a regular octagon, so all these sides are congruent. Again, not the prettiest of shapes, but we can make do. And we know that each side is 15. And we know that the apothem is 20. So for every square inches of area, I can have 1 inch of fish. I can have a fish that's 1 inch long. So if I had 12 square inches of area in a tank, I could have a fish that's 1 inches long as a general rule. So I need to find the area of this regular polygon. Well, if you don't remember, the area of a regular polygon is 1/2 times the apothem times the length of the side times the number of sides, which for an octagon is 8. So you have 0.5 times 20 times 15 times 8 gives him 1200. So this is inches squared. So for every 12 inches of area, 12 inches squared of area, I can have 1 inch of fish. So I need to figure out how many 12s are in this area. Well, 12,000 divided by 12, or 1,200 rather, which you can probably deduce is 100. So we can have 100 inches of fish in this aquarium, which basically means that if he measures all his fish and adds them together, that number should not go over 100. If it goes over 100, his fish tank is too small. If it's under 100, that means he has extra space, which is not bad. But it just means that he needs to be cautious of how many fish he puts in there so it doesn't go over that 100 inches of fish mark. Otherwise, it's an overcrowded aquarium, and then bad stuff happens. But even further, let's say there's like a doctor's office or something, and they want specifically goldfish. So all they want is goldfish in this tank. And they do some research, and they found that the average measure for a goldfish is usually 5 inches. So how many goldfish can they put in the tank? Well, you can have 100 inches worth of fish. Each goldfish is 5 inches. So it's just 100 divided by 5. You want to figure out how many fives, how many goldfish, can fit in a tank. So in this case, that ends up being 20. So this tank can hold 20 just pure goldfish there. If they just put just goldfish, you can put 20 of them in there, and you'll have a fine aquarium. You'll be right at the limit, so you can't add any more, and hopefully you don't get one that kind of grows really big and overcrowds it. But if you want to be up to the maximum, you can have at most 20 goldfish in this tank and be considered safe and within regulation and all that. Again, this one wasn't typically too difficult, but you had to kind of think about, okay, now that I have this area, how do I use it to get my next result? So we got the area, and then we use that by dividing it by 12 to get how many inches of fish we could have, because we want to figure out how many 12s were in this area, because for every 12 we get 1 inch of fish, and we found that it was 100. And then we had to figure out how many 5s were in that to get how many goldfish total. So that's it for this video. Again, this is the last of the review stuff we did before break. Next time we'll go over a little bit of a new lesson about similar areas so that you're ready for your assignment on Friday. Hope this helped you out. Have a good day.